A student was looking through the petabytes of images that have been collected by the telescope. So this object is only emitting radiation every 18 minutes.
Space exploration has provided us with a wealth of information, which has allowed us to create inventions and technologies that have made human existence simpler, while also allowing us to discover more and explore farther into the cosmos. What has NASA's telescope lately uncovered that defies all logic? Join us today as we introduce you to some terrifying regions of the universe and explore something that scientists cannot explain. WASP 76b is one of numerous exoplanets in the cosmos. It is a scorching exoplanet located around 640 light-years distance from us. However, the planet is also notorious for having a perpetual dark side and molten iron rains. It was discovered in 2016 and is approximately the size of Jupiter. Since it is tidally locked to a star, the planet is always facing it. The dayside temperature reaches 2,350 degrees Celsius, 4,300 degrees Fahrenheit. This is more than enough to evaporate metals like iron into the atmosphere. Furthermore, the radiation received by the dayside is millions of times greater than that received by our planet from the Sun. The dark side of WASP 76b is nearly twice as cold. Because of the high temperature differential, this exoplanet experiences severe winds. As a result, the winds transport iron vapor from the hotter side of the globe to the cooler side. As the vapor cools, molten iron showers down on this planet. That's strange enough, but not as strange as the planet known as PSRJ 17191438b. But what makes it so impressive? This exoplanet is 3,000 times bigger than its host neutron star. Furthermore, it was not always a planet, it was once a star. But first, let's go back to the beginning. The exoplanet is around 20 kilometers, 12 miles wide, and circles an extremely dense and small neutron star. On Earth, a teaspoon of this star's stuff would weigh billions of tons. The star is also a millisecond pulsar, emitting radiation beams every 0.4 milliseconds while rotating. This equates to about 10,000 rotations every minute. The star is not alone. It has a companion planet around 40% the size of Jupiter, PSRJ 17191438b. At the same time, this exotic exoplanet is larger than Jupiter. So how does it manage to be both small and massive? This is due to the fact that the exoplanet was originally a star, whose outer layers were torn away by a much larger neighboring pulsar. This resulted in the carbon remains of a star becoming a diamond world, roughly 5 times the size of our planet. It presently has a diameter of around 60,000 kilometers. Because the exoplanet is so near to the pulsar, the entire system may fit within the diameter of our Sun. In 2018, a dwarf galaxy known as Betan 1 was discovered in our Milky Way's intergalactic backyard, about 30 million light-years distant. As a point of comparison, the entire observable universe is 93 billion light-years across, so you can see how near this is to us. Because of its tiny size, low luminosity, absence of dust, and elderly stellar populations, Betan 1 is classified as a dwarf spheroidal galaxy. However, this newly discovered galaxy is unique in so many ways. To begin with, it is tiny, measuring just 3,000 light-years from side to side. To put this into perspective, consider that the Milky Way's famed spiral disk has a diameter of 100,000 light-years. Furthermore, Betan 1 is around 2 million light-years from any other giant galaxy, making it the most isolated dwarf galaxy ever discovered by man. Loneliness isn't necessarily a bad thing in the universe. It means that the dwarf galaxy hasn't had any interactions with other galaxies. However, the most important fact is that Betan 1 is estimated to be as old as the universe itself, roughly 13 billion years old. And due to this isolation, Betan 1 is the equivalent of a living fossil from the dawn of time. Only time will tell how many secrets this old galaxy keeps from us. When it comes to unsolved deep space mysteries, one thing is certain: there are still many outstanding things and objects to uncover. The global EMU project, centered in Australia, comprises a team of over 300 scientists from 21 nations. This team of experts is tasked with surveying the whole southern sky as far north as 30 degrees. The ASCAP telescope, which can survey wide swaths of the sky fast and look when no other telescopes have looked before, will be used by EMU to generate a better resolution radio map of objects in the southern sky. But assume for a second that you're one of the scientists utilizing this telescope and you happen to notice something so unusual that you end up calling it Object What the F***. This is exactly what happened in September 2019 to radio astronomer Anna Kopinski. She saw a strange form that seemed like a ghostly circle of radio emission hanging out in space like a cosmic smoke ring while reading through observations conducted by the EMU project utilizing the revolutionary new ASCAP telescope. A few days later, another EMU team member, Emil Leinck, discovered a second ring that was even creepier than the first. And despite ruling out all apparent explanations for these bizarre objects in their newest investigation, the EMU team is still striving to figure out where they originated from. The EMU astronomy team anticipated from the start that exploring the unknown would lead to surprising discoveries. They didn't expect to observe an abnormality like the strange orcs so early, and the discovery took the researchers by surprise. Although our scientists have a good knowledge of how our universe works, they have barely scratched the surface. To put it into context, astronomers focused the Hubble Space Telescope at a black speck of sky so minuscule it could be covered by Abraham Lincoln's eye on a dime held at arm's length some years ago. With that little patch of black sky, scientists identified 3,000 points of light, each galaxy containing an average of 100 billion stars. Only 4 of these orcs have been discovered in all of space. They have no idea what they are, how far away they are, or how they came to be. The scientists first believed the finding was caused by a software glitch, but they were quickly verified to be genuine after independent confirmation was supplied using the Australia Telescope Compact Array and the Murchison Wide Field Array. So far, scientists have only been able to rule out possible explanations for the mysterious circle. They can be observed in the radio spectrum, but when other types of telescopes were aimed at them, the unusual radio circles were not visible at all. None of the orcs had any evident optical, infrared, or X-ray analogues, making life tough for those investigating them. Orcs 1 to 3 were detected by visual assessment of EMU survey photos, whereas Orc 4 was located in archive data obtained with the Giant Meter Wave Telescope in March 2013. This indicates that prior to the ASCAP telescope, astronomers might have been looking at these objects for years without ever spotting them due to inadequate instruments. The most difficult challenge that astronomers face when it comes to orcs is that circular features are irregular occurrences in radio astronomy. They often depict a spherical object like a supernova remnant, a planetary nebula, or a star-forming galaxy. They may also result from image artifacts produced by calibration issues near bright sources. Orcs, on the other hand, do not appear to match to any of these recognized types of objects or artifacts. In fact, the 4 orcs are extremely similar in nature. They all have a strong circular symmetry and a diameter of around 1 arc minute or 1/60th of a degree. Despite their similarities, they differ sufficiently to confound astronomers. 2 of them have a galaxy around the center of their visible spectrum radio emissions, but the other 2 do not. Furthermore, 3 of them appear to be a party-filled ring, whilst Orc 3 appears to be a uniform disk. Another perplexing feature is that they are so close together, hinting that these 2 orcs have a similar origin. This is not the case for Orcs 1 and 4, suggesting that they are 2 distinct occurrences. When confronted with such problems, the scientific process is to gradually and painstakingly reject alternatives until scientists may claim to have discovered something really unique. That is exactly what the EMU team recently achieved, and their findings were presented in a research article for the Astronomical Society of Australia in November 2020. Here's what they discovered. The first thing they ruled out was the Orc being a supernova remnant, or SRN. SRNs are structures formed by the supernova explosion of a star. The remnant is surrounded by a growing shock wave and is made up of ejected material from the explosion. The scientists that studied the Orcs discovered that the possibility of one of them being a supernova remnant is merely 0.055%, while the probability of the other three being SRN is 2.1 times 10 to the power of -5%. As a result, it's doubtful that the Orcs are supernova remnants. The second alternative was that these strange radio circles were galactic planetary nebulae, which may likewise appear as dispersed disks of radio emissions like Orcs. They originate near the twilight of the life of a star, with an intermediate mass ranging from 1 to 8 solar masses. In fact, near the completion of a star. Its life cycle, our Sun will similarly generate a planetary nebula. However, because PNE radio emission is caused by thermal emissions, it is projected to have a significantly higher spectral index than those found for the four odd radio circles. Simply said, the proportional connection between the amount of power emitted via a given area and the frequency of the radiation is substantially lower in the case of an Orc, barring them from being categorized as PNEs. Other alternatives, such as the Orcs being part of a star-forming galaxy or a ring galaxy viewed from the front, were also ruled out by the EMU team. All of these galaxies are luminous and have optical wavelengths, in contrast to the Orcs' absence of measurable optical emission. For the same reason, they cannot be regarded a component of a double-lobed radio galaxy or a bent-tail radio galaxy. The circles might also be an Einstein ring, which is a gravitational lensing of background sources that produces emission arcs. When a source, lens, and observer are all aligned, the lensed image can take the shape of an Einstein ring. However, in the case of Orcs, such a lens is unlikely to be sufficiently symmetric and completely aligned with the background source to create the observed circular symmetry in an Einstein ring. They've also ruled out the possibility that these Orcs are other astronomical phenomena like gravitational termination shocks or cluster halo, both of which are detected when a neutron star goes supernova. The majority of astronomical study is focused at improving our understanding of the cosmos or testing hypotheses. Rarely do astronomers face the difficulty of discovering a new sort of object that no one has ever seen before and trying to figure out what it is. The story behind these new spooky circles continues. Astronomers must constantly ask themselves if these Orcs are a completely new phenomena or something they already know about but have been examined in an unusual way. And if it is truly unique, how does it alter our knowledge of the universe? So what do you think? Let us know in the comments.